All right, so we are ready to start with an example of a hypothesis test for two population means. So we're going to read through this example together. And it says here, a psychologist is interested in the effect that no sleep has on individuals' abilities to perform motor tasks. She selects 25 college students, we're going to call that group 1, to stay up all night, and she selects another 27 students, group 2, to sleep. The students then attempt to make 20 free throw shots with a basketball. So each student tries to make 20 shots. And group 1 makes an average of 8 shots with a standard deviation of 2.3. And group 2 makes an average of 12 shots with a standard deviation of 3.4. And what we're asked to do is test the hypothesis that those who stay up all night have a decreased ability to perform motor tasks at the 5% significance level. So first thing we're going to do here is we are going to try and determine whether we need a 2-sample z-test or a 2-sample t-test. If you take a look at the data, so we have group 1, and we're given the mean for group 1, and we're given the standard deviation for group 1 from the data. So that means that is a sample standard deviation. And then for group 2, we're given a sample mean and again a sample standard deviation. So because we have those sample standard deviations, we are going to use a 2-sample t-test. Just as a reminder, so we don't get confused later, group 1 is our group that did not sleep. And group 2 is our group that did sleep. Okay, so we're going to start with the normal step 1 in performing a hypothesis test, which is to state our significance level alpha. And we're given a 5% significance level, so alpha is 0.05. And then the next thing we need to do is state our hypotheses. So the null is going to be no change or no difference from what's expected. And so if the treatment, which is staying up all night versus sleeping, if there's no effect, then the mean for group 1 should be the same as the mean for group 2. And what we're trying to test in our alternative is that those who stay up all night have a decreased ability to perform motor tasks. So those with no sleep would make fewer shots than those with sleep. So that means that we're testing that mu1 is less than mu2, which is a left-tailed test. Okay, next step 3, is to calculate our test statistic, and we're going to go to the calculator to do that. And so if we go to the calculator, we're going to stat. We are scrolling over to tests, and we are doing a 2-sample t-test, so that's option 4. So it's asking us if we are inputting the entire data set, which we don't have in this case, or just summary statistics. We're entering in summary statistics. X1 bar, so that is the sample mean for group 1, and that was 8. S sub X1, that's the sample standard deviation for group 1, which was 2.3. And our sample size for group 1 was 25 students. X sub 2 bar was 12. S sub X2 was 3.4. And N2, our sample size for group 2, was 27 students. We are choosing a left-tailed test, so mu1 is less than mu2. When it asks you here pool or not, that's referring to whether or not we're pooling those sample standard deviations. We're going to always select no for this class. So we've got no, and then we're scrolling down to calculate. So we've got our test statistic here of negative 5.00098. So I'm just going to write here t equals negative 5. We'll call it 001 if we round. And our p-value, if we look back at the calculator, the p-value was, and we got to be really careful here. This says 4.3996, and I'm going to see a lot of students write that as the p-value. But remember, a p-value has to be between 0 and 1. It's a probability. And so this is 4.3996 times 10 to the negative 6th power. So this is a very small p-value. That negative 6 means we have to move the decimal place 6 places to the left. Okay, so that p-value really ends up being 0.0000004 if we round that. Okay, that was step 4. Step 5 and 6 are the steps we usually combine. That's where we are deciding what decision to make. So we're comparing our p-value to alpha, and if our p-value is less than or equal to alpha, that's when we choose to reject our null hypothesis. You can tell in this case our p-value is definitely less than 0.05, and so we will in fact reject the null. And then our last decision here at step 7, or I guess not decision, but our last step is to make our interpretation. And so we would say at the 5% significance level, the data provides sufficient evidence to conclude that those who stay up all night have a decreased ability to perform motor tasks. Than those who sleep. Okay, so at the very bottom of this page, it asks us if the alpha level had been changed to 0.01, would that change your decision? In this case, our p-value was so small already that not only is it less than 0.05, but it's still less than 0.01. And so in this particular case, changing that alpha level wouldn't matter. If you happen to have a p-value that, let's say our p-value had been like 0.03, if our p-value had been 0.03, we would have rejected at the 5% significance level, but we would not have rejected at the 1% significance level. And so I just wanted to make sure to mention that, because that is why we always state in our interpretation here the significance level of the test, so we know at what level we rejected it. And most studies are also going to report the p-value so that you can make that decision on your own.